All right, number 21. We have tan squared t over secant t. And let's go ahead and start with that one. Let's start with that side there. Let's change tan squared with a Pythagorean identity. So it's going to be secant squared minus 1. And that's what tan squared is going to equal if I take away 1 for both sides. So let's change that tan squared into secant squared minus 1 all over secant. And then I'm going to break up my fraction. So I'm going to have secant squared over secant minus 1 over secant. Remember, you can break up the numerator, but you can't break up the denominator. Now, secant squared over secant, one of those is going to cancel, and I'm just going to be left with secant. And 1 over secant, that equals cosine. So I get secant t minus cosine t. And that was my goal. Let's do 23 the same way. So I'm going to go ahead and start with the right, and let's break up the fraction. So we're going to get 1 over sine minus cosine over sine. And I'm sorry, I'm starting with the left. 1 over sine, that equals cosecant. Cosine over sine is cotan, and it looks like I got what I wanted. Now I think that we can start a few different ways. Let's try to get common denominators here and add these fractions. So it looks like here I'm missing a secant, and over here I'm missing a cosecant. And if I do that, I'm going to get secant times sine plus cosine times cosecant all over secant times cosecant. Now, if I have to keep going and multiply these, I'm going to have to do a lot of switching sines and cosines. I think I'm going to try to go a different route. Let's go ahead and start over. So sometimes it's best just to start fresh. Let's simplify each of these fractions separately for a minute. Let's go ahead and take the denominator of the first one and change it to 1 over sine. And let's change secant over here to 1 over cosine. Now, dividing by a fraction is like multiplying by the reciprocal. So on the first fraction, I'm going to be left with a sine squared. The second one, a cosine squared. And I know from Pythagorean identities that sine squared plus cosine squared equals 1. Looks like that was a better route to go. Now, obviously the left is the more complicated side, so let's start there. Let's change tan to sine over cosine. And then let's go ahead and get some common denominators. Let's see where that takes us. So we need 1 plus sine t here. And over here we're going to need a cosine. So if I distribute in the first side, I'm going to get sine t plus sine squared t plus, and in the second one I get cosine squared t. In the other one, I'm going to have cosine t times 1 plus sine t in the denominator. Now, sine squared plus cosine squared equals 1. So I have 1 plus sine t in the numerator. Cosine t times 1 plus sine t in the denominator. 1 plus sine t's can cancel now, and I get 1 over cosine, which equals secant. 33. Secant squared x cosecant squared x equals secant squared x plus cosecant squared x. Let's start with the right side. And let's see here. Secant squared. Let's change that into tan squared plus 1. Using our Pythagorean identity. And let's change cosecant into 1 plus cotan squared. That gets us to 2 plus tan squared plus cotan squared. Now, to me, I don't think I'm getting much closer to where I want to be. So let's go ahead and go back and let's try again. Let's try a different route and see something else, if we can try something else. Let's start with changing secant. Let's make this one 1 over cosine squared. And this one 1 over sine squared. Let's go this route. Let's see if this helps. And let's try to get some common denominators. So this one's going to need sine squared and sine squared. And this one's going to need cosine squared and cosine squared. So on the top, I'm going to have sine squared plus cosine squared. And on the bottom, I'm going to have sine squared times cosine squared. Now, sine squared plus cosine squared equals 1. So we get 1 over sine squared cosine squared. And if I take the reciprocals of both of those, I'm going to get cosecant squared and secant squared. And that looks more like what I wanted. And those are equal. You can see you're not always going to get there the first time around. 35. All right, let's start with the left side. And let's try putting everything in terms of sine and cosine. So we're going to get 1 over cosine minus 1 over sine all over 1 over cosine plus 1 over sine. Now let's look at each separately. We need common denominators on the top, so we're going to need a sine x here and a sine x there, and a cosine x here and a cosine x there. So in the top, we're going to have sine x minus cosine x all over sine x times cosine x. Now that's just the numerator. We need to do the denominator as well here. So let's go ahead and look at the denominator. In the denominator, I need to do the same thing. I'm going to need a sine x and a sine x and a cosine x and a cosine x. So the denominator is going to be sine x plus cosine x all over sine x, cosine x. It looks like those denominators are going to cancel. And I'm going to be left with sine x minus cosine x all over sine x plus cosine x. Now, it's supposed to be getting to some tangents here. And And we're not there yet. So we're going to do something we haven't done before. We're going to stop where we are, and we're going to go to the other side. A method we haven't used yet is to take the other side now, and let's work that around a little bit. So let's just work on the other side for a second. Let's change these into sines and cosines again. Now notice I'm not adding and subtracting to both sides at all. I'm just working on the other side independently from the first one. If I get common denominators again, we're going to need this to be cosine over cosine, and cosine over cosine. And now I'm going to get sine x minus cosine x all over cosine x in the numerator, and sine x plus cosine x all over cosine x in the denominator. And those common denominators are going to cancel, and I'm left with sine x minus cosine x over sine x plus cosine x. And you can see our left side and our right side are equal. So this is a different way to verify these identities. Looking at the last one, sine squared x minus cosine squared x. All right. Let's see. Let's go ahead and let's change sine squared. Now let's change cosine squared to be 1 minus sine squared. And we'll see where this takes us. I don't know what's going to happen here. All over sine x plus cosine x. If I do that, I'm going to get 2 sine squared x is minus 1 over sine x plus cosine x. I'm going to stop right here. It doesn't look like we're getting any closer to what our goal is, so I'm going to start over and try something else. Now if I go back and try to start over, I see also that I have something that looks like this, x squared minus y squared. And that's the difference of two perfect squares. Let's split this up into sine x plus cosine x and sine x minus cosine x. Now, if I look at the whole bottom, that matches one of my factors there on the top, and I can cancel those out. And I'm left with sine x minus cosine x, which is exactly what I wanted.